Hello, everybody, and welcome to another installment of Not Your Professor, your one-stop shop for everything from mitosis to MDMA. We explain science in a way that makes it stick, factual, concise, and explicit. We post weekly videos tailored to a variety of different scientific topics to help students learn and retain information in a way professors simply cannot. Bring your smelling salts, join the wave, and subscribe. Proteins are an extremely refreshing break from amino acids that will undoubtedly haunt many of your dreams, especially if you plan on taking the MCAT, because they stuff that thing fuller than a bag of dicks. I'll let your imaginations take over for that one. Much like amino acids, we will need to break it down into parts so that we do not short-circuit the peanut brains I know many of you possess. Luckily for you all, or at least kind of, depending on how you actually plan on studying, these are much less focused on memorization than amino acids. But as with all the shitty things in science, the information from the past will come back to haunt you. Proteins are polypeptides consisting from anywhere from a few amino acids to thousands of amino acids. The amino acids are made through, come on, say it with me, peptide bonds, which are formed via dehydration reactions. This is absolutely a favorite question for many professors, so make room in your long-term memory for that because it ain't fucking leaving. Proteins can play a myriad of different roles within the body, from hormones to receptors. Hey, how do you make a hormone? You don't pair. Alright, anyway, which is as scary as it sounds, we're just going to cover the basics of structure before we get into the nitty-gritty. Now, the structure is broken down into 4 levels: primary, secondary, tertiary, and quaternary. It would be convenient if they stayed in chains of amino acids, but trust me, nothing in the body will ever be that easy. I'm going to do my best to be as succinct with my description of each level of structure, because it can get fucking complicated, so listen up. The primary structure of amino acids is the most simple, just the sequential arrangement of the amino acids. This is as simple as N-terminus, proline, valine, histidine, alanine, and tyrosine, C-terminus. Because of how ridiculous it can get writing each one of these out, this is where those pesky fucking abbreviations make their appearance. Now, the 3-letter abbreviations are easy if you can comprehend at a 3rd grade level. But as we know, the single-letter abbreviations are an absolute clusterfuck. But they are necessary when amino acids and proteins get built up, like this one right here. So it's absolutely important to make sure you're on top of that. It is also worth noting that this structure is stabilized via covalent bonds between adjacent amino acids. The secondary structure is essentially the local structure of neighboring amino acids. This interaction is caused by hydrogen bonding between amino acid chains. What you need to realize is this protein structure is essentially just a bunch of stabilizing and eventual unfolding of different chains. This seems complicated, but there are just 2 structures you need to know for this, thank God. Alpha helices and beta pleated sheets, and they are exactly how they sound. Alpha helices are exactly what you think they are, a helix of amino acids, basically a rod-like structure where amino acids coil clockwise around a center axis with the side chains pointing outward. I know what you're thinking, oh yeah, just like DNA. No, fucking Momo, DNA is a double helix, so you're going to fuck yourself up if you try to think that way. Now, beta pleated sheets are also exactly what they sound like. Just picture a pair of pleated khakis. Before I go any further, I gotta mention, pleated khakis are for fucking virgins. And I'm not talking 16-year-old never seen a pussy virgins. I'm saying more farmersonly.com virgins. Unless you are under the age of 10 or plan on becoming a priest, do not wear them. Alright, back to the fun. The pleated sheets consist of polypeptide chains forming rows with the R groups pointing above and below the plane, further stabilized by hydrogen bonding. Tertiary structure is where shit starts to get a little bit wonky. This shit can get intense. I'm talking about cutting onions while watching the Green Mile intense. So do your best to pay attention here. The tertiary structure is a 3D shape of a polypeptide chain. What makes it complicated is how it is made up. The structural components are determined by, who would have guessed it, R groups. This makes it easier than it may appear. Hydrophobic R groups, which just means they don't like water. Think of arachnophobia or homophobia if you're dumb and you have a brain stuck in the 1970s. Anyway, hydrophobic R groups are typically found on the inner portion of proteins. If you can put 2 and 2 together, this would mean that the hydrophilic R groups, typically the more charged or polar R groups like serine and histidine, are found on the outside. This is further stabilized through electrostatic interactions between amino acids as well as hydrogen bonding. Finally, quaternary structure is a conglomerate of 1 or more polypeptide chains. Not all proteins have quaternary structure, as some just exist as single polypeptide chains, but you can have a number of different effects on promoting stabilization or bringing catalytic sites closer together, for example. Now, this is all I'm going to touch on for that because honestly, unless you're in graduate school, most sane professors won't go any further. But it's still worth mentioning because most large proteins you see within the body are going to have a quaternary structure. There are two last things that need to be touched on before we are ready to move on to more protein stuff next week. The first is prosthetic groups. Much like prosthetic limbs, prosthetic groups attach onto proteins covalently. They form conjugated proteins, which are just proteins with an extra group attached. These groups can range from a myriad of different organic molecules, vitamins, fake tits. Okay, well, maybe not that last one. We'll save those for the girls whose dads just simply can't say no. These groups help determine what role a protein will play in the body for each respective protein that is affected by them. The last thing I need to touch on is denaturing. Denaturing is the loss of a protein's three-dimensional structure. Imagine you are at a party playing stack up and you have to drink the middle cup. After you finish the mixture of beer, vodka, and whatever else was in arm's reach at the time, you start to break down into the shell of person that you once were, and you wake up on a bus stop bench. In a similar way, proteins begin to lose shape and break down. Denaturing is often caused by either heat or solutes. Heat can overcome the hydrophobic interactions that hold proteins together. An example of this is when an egg begins to turn white when fried. The protein begins to denature and unfold. Fuck off, that is a fun fact. Solutes, on the other hand, can disrupt the forces holding the proteins together. That's a wrap for this week's Not Your Professor. Hopefully you can tune in next week for more protein stuff. As always, like and subscribe, and feel free to roast me in the comments with whatever qualms you may have. Peace out.